Distributed databases are difficult to operate, and Crateio wants to change that. Crate is a fast, scalable, easy-to-use SQL database that is built to run in containerized environments. An average software company runs several databases: MySQL for relational store, MongoDB for a document database, HDFS for blob storage and data warehouse, Elasticsearch for search. Do we really need all of those databases? On today's show, Jodok Batlogg from Crate discusses the architecture of Crate, and he breaks down the use cases, from microservices to data warehousing. Many fans of Software Engineering Daily are listening right now through the internet browser. The practical developer is the best place to get that experience through the browser. And the practical dev has teamed up with Software Engineering Daily to give us a better browser experience. Practical dev is the place to read and listen to content about Software Engineering Daily. Check out our new site at dev.to/sedaily. That's dev.to/sedaily. After a quick word from today's sponsor, we'll get to this episode, Distributed SQL with Crateio. Podcasting full-time is a great career, but if I ever return to the normal world of work, Hired.com is where I will start my job hunt. Hired.com removes the frustration of searching for a job. You just fill out your profile and the jobs come to you. Facebook, Uber, and Stripe are a few of the companies that are hunting for engineers on Hired. Go to hired.com/sedaily to try it out and get an extra $1,000 signing bonus just for using the URL for Software Engineering Daily listeners, which is hired.com/sedaily. So if you want to try it out, go to hired.com/sedaily. The demand for engineers is higher than the supply. And on hired.com, that translates to higher salaries and happier careers for the engineers who find a job on Hired. I used Hired to find a job before I became a full-time podcaster. And the experience was so good because Hired connected me with a talent advocate who worked with me to find a job that was a good fit. And the talent advocate answered my questions about negotiating salary and finding remote work, which was something that was really important to me at the time. So check out hired.com/sedaily and get a $1,000 signing bonus upon finding a job, which will be a great job that will give you the respect and the salary that you deserve as a great engineer. So check out hired.com/sedaily. It would support the show. And now let's get on with today's episode of Software Engineering Daily. Jodok Batlogg is the CTO of Crateio, a containerized distributed SQL database. Jodok, welcome to Software Engineering Daily.
Thanks for having me.
Absolutely. So when you started building Crate, there were some problems that you saw with modern databases. What were those problems?
So the biggest problem was the scalability of existing systems. You have to set up master-slave configuration, replicas, things like that, worry about sharding. And that was really a pain in the ass. So when we were running large sites, we always had the problem that the data layer was really hard to manage. But the cool thing was we found about the technology named Elasticsearch in already 2010. There was just one guy sitting in Israel working on a real cool software based on Netty, non-blocking, evented.io, all that stuff. And we thought that's really great architecture and we would like to build a database like that. That's how we started.
So talk more about Elasticsearch and why this is relevant, because many people will hear Elasticsearch and they're like, that's not a database, it's something to do with search.
Yes, absolutely. It's also got like 2 years ago on the Jepsen test, rather bad reports about losing data, about not being persistent. But hey, it's an open source project. A lot of bugs have been fixed, has a very good track record of not losing data. And also the status page on resiliency and failure is really, I think, one of the best open source documented things. There has been a lot of work going on. So I think it's totally fine to use it as a database. Also, if you have replicas enabled, and what we also hear from customers, also from other users, not necessarily only of Crate, but also of Elasticsearch. This is usually a very rare edge case where you can still have these situations, like in any software.
Could you talk more about the storage model and the data model of Elasticsearch? I haven't done a show about it, and I don't know if the average listener knows how Elasticsearch models, relative to, I don't know, some other database type that we've done shows on, like relational databases or NoSQL databases.
Yeah, so that's a good point to look at the whole sandwich of open source software that is being used there. So we focus at Crate at the query engine and at the SQL parser executing these queries. This is what we care about. The one layer below is the whole network protocol, how the nodes talk with each other, how they discover each other, how they transport data. This is mainly Elasticsearch IP. And of course, also utilizing Netty for that. The actual storage is done in Lucene, which is the mini database. Probably think of other people might use SQLite and then cluster it. The choice of Elasticsearch and us is to use Lucene for that. And that's also, people don't think, why Lucene? Is this really a database? Yes, it is. It also already has transactions. It has a lot of functionality built in there that makes it a really great database.
Okay, so let's talk about some of the other database products on the market. Perhaps we can contrast that with Elasticsearch or with Crate as you see fit. So we did a show recently about CockroachDB, and in that show we explored some of the typical trade-offs between relational SQL databases and NoSQL databases. From your point of view, what are the trade-offs between these two database types, and also, the trade-offs between how they are positioned versus Lucene?
Yes, so that's a big bet. Is it about eventual consistency, or is it about strong ACID transactional stuff? And the Cockroach guys, they're using RocksDB and build a strongly transactional layer of key value store as base. And on top of that, they add layers like SQL. This has some advantages when it comes, to transactions, to strong ACID compliant cases. But if you go for performance, if you go for changes of cluster, if you go for other patterns, for other things that are important, we think the eventually consistent model is the better approach. So maintaining Elasticsearch cluster, but also we have the same characteristics there. So managing a Crate cluster is much easier. And also, if you run in a rough environment, think of a Dockerized environment where you probably have nodes with some load. You might have some network latency there. You might have nodes coming and going, and maintaining the whole guarantees you need for having synchronized clocks and writing that stuff. This is definitely causing some overhead. So my suspicion is also what I have seen from FoundationDB. You probably remember these are the guys that were snatched by Apple, I think, about a year ago or something like that. They built on a very similar model like Cockroach that was hard to scale beyond 20 nodes. I bet using Raft protocol and things like that might probably make things easier. However, we're going for the eventual consistency. We are not trying to be ACID compliant. We give people guarantees like read after write consistency. We do optimistic concurrency control. We're resolving errors on the server side. So we're going for conflict-free algorithms. It's a different way we're going. And I'm looking forward to see how the market evolves there.
Very interesting. Okay, so let's talk some more about from a usability perspective. So if I'm an average software company, I've got my backend database that's probably siloed into all these different use cases. Like I've got MySQL for a relational store, MongoDB for a document database, HDFS for like blob storage and a data warehouse. And I've got Elasticsearch to power my search. I've got all these different databases doing different things. So at a fundamental level, in the past, why have we needed different databases for different application types? And has that changed? Do we no longer... Has this all been rolled into one with Crate? Is that the offering?
Yes, that's definitely, we call this the zoo of technologies. And
not to do your marketing for you.
We have a slide on that in our deck where we exactly paint this picture. And we call it the zoo of technologies with elephants and all other animals running around there. They have names. They need to be petted. They have special places where they live. We take more the approach of being cattle that is just out there, omnipresent and always on. So I think as data is exploding, there's definitely room for new databases for different databases. I mean, 200 might be probably too much. If you look at DB engines or something like that, there are a lot of databases out there. We did it because we had a specific need. I was running a service business. We did projects with real customers, with real problems that we solve. And that's how we came up with our solution. So the cornerstones that are important for us, the first of all is simplicity. Really having someone that is not an experienced database developer or sysop to run a database. I mean, Cassandra is a super stable thing, but you need to be a pro to run a Cassandra cluster in production. Same goes with MongoDB. It's very easy to get started, but then maintaining it if you have different node types, and that's harder. Also Hadoop, I mean, maintaining a Hadoop cluster is a nightmare. And we've done this for customers. They paid us a lot of money for that. So the thing we took was also using SQL because, I mean, still nowadays in university, people still learn SQL. They do all the stuff. They think like that. They have object relational mappers. And I think SQL is very strong. And still, it's probably too much, the whole transactional stuff, and also having strict schemas. So we're going for object columns where you can store JSON. We go for full text indexing. We go for geospatial support. We go for even custom data types that can be stored in the columns. And so taking the simplicity, taking SQL, taking scalability, and focus on the sub-second responses. So not batch-oriented, whatever, but stay in the sub-second response time. That's where we see our sweet spot, and that's where we see not a lot of competition in the open source space.
So maybe we're going to need to go deeper so I can understand this, but like I'm having trouble understanding what are the trade-offs. So like I get that you have all these pieces of functionality that are all in the database, that are all have within Crate, but I'm still having trouble understanding where the trade-offs are coming in. Is it just the fact that you had to do so much work up front doing the underlying plumbing to expose a simple API to people, or what exactly? Like, how did you roll all this functionality into one database without making trade-offs, or what were the trade-offs that you're making?
So I think the trade-offs we're making is, for example, large result sets. If you have queries that really yield in whatever gigabyte of result sets that you have to consume, like Hadoop is very good at, that's not something we can do. We don't have any job control or something like that. It's just you fire a query, it's being answered, you fire 10,000 of queries in parallel, we consume them. The other thing that's also a trade-off, and I'm not sure if we ever will get to that point, are transactions. So we have read committed workloads means, so if you start a read transaction or a read operation, it's consistent. Even if it's running for 10 seconds and you delete data, meanwhile, you have a consistent result. But opening a isolation context for writing a couple of records and then roll it back or commit it, that's not something we can do. And also going for standard SQL and not inventing a new SQL dialect is also hard because we still don't have the full SQL 92 spec. So adding more and more SQL functionality, stuff that people need all the time, that's something that is hard for people to use. Joins, for example, was a very good example. That's also something that took us a very long time, I think close to 8 months to get joins done right. Also do it in a distributed way and in a scaling way. This is where our query engine is coming in.
Crate is open source. Could you give me an idea of what the initial version of the code base looked like when you guys open sourced it at first?
Oh yeah, I remember that. I was with my family at the pool. I had my mobile phone somewhere in pocket. And then I was just full of messages and, hey, where are you? And missed calls. And we got featured on Hacker News. And we had like, I don't know, it was just crazy because so many people looked at us. And what we had there was a simple thing that could understand SQL and then was firing queries basically against Elasticsearch. All of that was wrapped in that container, but it was not much more than just translating SQL into Elasticsearch queries. And we were using DB SQL parser at that time and had a very minimalistic framework. Yeah, and then from there, we basically ripped out the entire query engine that Elasticsearch was using, put in our query engine, and still maintains to be in sync with upstream. So just this week, for example, we announced also we had the nightly build that is already using the latest 2.x series of Elasticsearch in the core.
Were people most excited at first about the fact that you were translating SQL into Elasticsearch? Or I'm sorry, SQL into Elasticsearch, right? Is that what you said?
Yes, we thought, but it was not the case. It was also when we were at meetups and telling people what we're doing, they said, why should I do this? I'm using a search engine. I don't need a database. And it was really, they didn't get it. It was more the people. And yeah, that was also a little bit misleading because we thought like this general purpose database that everybody could use and that is resilient and just use your small web app and make it grow. But it turned out that the real potential was in this whole thing that is between analytical processing, where people do big queries, have data warehouses and that stuff, and operational things. So they are combining their operational database that needs to scale with the analytical capabilities in one database. So typically something people use HP Vertica for, or some Teradata stuff or Oracle stuff. And that's what we learned over the last couple of months, that this is the sweet spot for what we're doing and not just the general purpose database thing.
Okay. So I think, correct me if I'm wrong, but I think what you're touching on is kind of this gradient between OLTP and OLAP. Is that right?
Exactly, yeah.
Okay. And so there's some other things that are kind of along this gradient, like Druid and I guess PhiloDB or Cassandra. Give me an idea of how people are exploring the different areas of this gradient, and what are the trade-offs that you make as you explore the different areas between OLAP and OLTP? Why is it hard to get both of those pieces of functionality right at the same time?
I think the magic, or the reason why this works so well for us, is again also using Lucene as the underlying store. With these field caches and this columnar store, it allows us to do things that other can't do. So I think we need some column-oriented approach to have this performance on large data sets. And also, we don't know exactly what people are querying there. So every database that is optimizing beforehand for the query pattern afterwards, they're having a hard time in this analytical stuff because you don't know where the people will drill down, what will they ask. And the way it is architected in our system is that these values can be loaded into memory. So if you do an aggregation on a revenue, for example, or you max, min, average, whatever, then all the unique values of that column can be loaded into memory. And then all the operations there are running in memory. So you only need the amount of memory available for the unique values per column. If you have 1 billion records and you only have 1 million unique values, you only need the memory for 1 million values. And we can do this for every column. So based on the columns you're running the operations on, these are being loaded into memory or evicted from memory. And this architecture allows us to have close to in-memory performance on most of the aggregations, and also using a modern framework that is using this evented non-blocking I/O that is super fast in transferring data via network. So these aggregations can run in a distributed way. So the combination of having these Lucene objects and caches below the hood and having a super fast processing framework on top of it allows us to do things much better than most of our competitors there.
Great. Okay. So I want to talk about some more aspects of the architecture, which is containerized. So
Yeah.
Crateio is built to run in containerized environments. What do you do to make Crate run particularly well on a Dockerized architecture?
So the one thing is definitely the storage. So we store copy on write files where we append if we're writing. That makes it easy to replicate stuff over the network. So as the beginning of the file is not modified anymore, it can be started to be streamed to another machine if you're creating a replica while you still write to the end of the file. And that allows to have an incremental way of moving data, of adding additional replicas while you are writing, while you're deleting on the database. So all the stuff, moving shards between machines, creating new shards, things like that can be done while the database is running. And that's very, very powerful because usually you have to take it offline for maintenance, for adding columns and things like that. So that change of the size of the cluster, of the number of shards, of the location of the shards, that is quite easy. That makes it a very good citizen in that container ecosystem. And the second point is the simplicity of the configuration and of the management. So there's only one config file. All the nodes have exactly the same config files. There's nothing special there. However, there's one, I have to mention this one master is elected for changes in the cluster state, but this is not a configuration thing. It can change there. So probably not worth mentioning, but other than that, all nodes are the same. So yeah, that makes it super easy to spin up a cluster.
Let's talk more about that. Explain this idea of a masterless architecture.
So yeah, masterless architecture, share nothing architecture that allows you to go really in high concurrency. So think about you have multiple processes ingesting data and you have multiple disks being able to store the data and you have multiple network interfaces and processors that can process the data. So you need to find a way that they can do this independent from each other, that they don't have to wait for acknowledgement somewhere or that they do not rely on a component that is always available. Because all of this is causing contention and is causing delay and is making things slower. So everything we do in ingesting data, on reading data, and computing data is built around this principle where all the things can run in parallel without congestion.
Okay, and Crate has just one container on each physical node, is that right?
Yes, what people typically do is they want to utilize local instance store because the disks are there. They probably have local SSDs that are cheaper. They don't want to use network attached storage that is expensive and slower. And they still want to isolate the database from their application. So they, most of the time, they just run one Docker container per machine. They expose one or multiple host volumes. And then they point their application just to localhost and Crate. It doesn't matter to which Crate node you talk. They can answer all the requests and they can delegate the work to the other nodes that are holding the data. So Crate is lying there like ether. It's like always a base layer that is providing persistence and that can grow and shrink with the number of servers you're also using for your application.
What happens if a Crate node dies?
So we are sending cluster check about every second. It's configurable where all the nodes are synchronizing. And if one node fails, it's taking out of the cluster. So he had some primary shards where he was the master for these shards, and he had some replicas where he was holding copies of the data. So another node that was holding replicas of his primary shards, this node is going to be promoted as a master and is taking over the master for these primary shards that are lost now. And then we have, of course, some missing replicas because we are under-replicated now, like a RAID system that has a disk failure. What Crate is doing is it's starting to create other shards on other machines and creating, again, the replication factor that was wished for the data. So for a short moment, the cluster is in the state of under-replicated shards. It's taking some background activity to recreate them. That's what usually happens. For the end user, okay. Nothing.
Of course. Seamless. Software engineers are always looking to automate their work. Software automation lets us get more done with the same number of resources. Investment automation works the same way. Wealthfront is an automated investment service that relies solely on software to acquire and manage client accounts. Traditional investment services have many humans in the loop, advising clients and taking fees. The problem with these older advisory services is that the advice that these services are applying is often so systematic that a computer could give the same answer, or an even better answer. Wealthfront takes a new approach with software-driven automated investment that provides better returns through software engineering. Go to wealthfront.com/SE daily to get a special offer for our listeners. $15,000 managed for free when you open your account. Don't pay commissions and account fees. Maximize your gains with Wealthfront's Set It and Forget It investment automation. Check out wealthfront.com/SE daily. It would support Software Engineering Daily, and it would also introduce you to the world of automated investment, so you can see if you like it or not. Wealthfront.com/SE daily. Thanks to Wealthfront for sponsoring the show. You've been a loyal sponsor, and we really appreciate it. Now let's get on with the show. So, okay, I want to zoom back to a bit of a simpler question, which I think is still going to have a complicated answer, but give me an idea. What'd you say?
I'm doing my best to give an easy
Yeah,
answer.
well, no, it's good. Complicated answers are good. But explain just top to bottom, how does a read work and how does a write work for a Crate database?
Yeah, so the simplest read is just getting a value, a key. So you have the primary ID, you want the record. It's hitting one node. The node can be using a consistent hashing algorithm to find out where the shard is. We make a request to that shard, pull out the record, return it to the client. Easy, super fast, 0 point something milliseconds. The second one is if we, let's say, want to have multiple records that are distributed across multiple shards. So there's a broadcast sent to all of the shards that are part of that query, not all tables, but just the table you were asking for or the partition you were asking for. Then these shards are collecting the data, the potential candidates for that query. Then they're filtering like a where clause or something like that, sending it to the node that did the request. This node is merging the sub-results, the partial results to a whole result, probably also doing some more sorting on these pre-sorted sub-results, and then returning it to the client. That's also everything so far is also true for the way Elasticsearch is doing it. The interesting part starts if you do distinct counts, if you do group bys, if you do joins, things like that. There we have a third phase that is happening after the collect phase, where data is being reshuffled in the cluster to be also aggregated in a distributed way. Think of MapReduce, but in real time. And there we have this 3 phases query, collecting, reshuffling, merging, and returning it to the client. That's a short answer to how the read works.
Sure. No, that's definitely a good enough answer. So,
the write, probably the write, that's easier because in the write, it's just, we have 2 writes, a bulk write or a single write. And there you just take the hash of the primary keys or of the routing keys. Then you send it to the shard that is responsible for that. You write it there, including also the replicas. And then you return to the client. So that's rather easy.
Okay. Very cool. So I want to talk about deployment across your architecture. So like if I deploy a database on a distributed system with different types of nodes, this can make things more complex. How hard is it to deploy Crate across a heterogeneous architecture with all kinds of different nodes?
So the way we deal with this is you can attach routing policies to tables. So a common scenario is that you have a couple of slower, cheaper nodes with SATA drives that have big storage, and you have a couple of nodes that have more memory and have SSD disks attached, and you still have a data set that is doesn't fit into where you have to distribute it between these nodes. So the older data that is not frequently accessed on the slow nodes, and the hot data on the fast nodes. So what you can do is you can tag the nodes with arbitrary tags, SSD or something like that, and then you can specify a policy It's a SQL command where these shards should be located. And then the system is taking care that they are located on these nodes. You can also use this if you want to have availability zones or things like that.
Okay, great. So speaking of large distributed architectures, we've done a bunch of shows recently on Kubernetes. Could you explain why Crate works particularly well with Kubernetes or Mesos or any of these other containerized distributed systems?
Yeah, so we are happy that we're not part of the war between the orchestration frameworks. So this is...
They certainly don't. They don't frame it like a war. They frame it like it's just this peaceful alliance between different schedulers.
Yes.
Yeah.
I'm happy that I don't need to have an opinion which is best or which works best. We're working with all of them. All of them support Crate. They have, of course, some advantages, disadvantages. What the most common thing we have to take care of is node discovery. How do they solve node discovery for clusters? So a lot of the tools initially came from the orchestration of stateless things like multiple applications. When it comes to scheduling a database that has state, it's a little bit more difficult. So Kubernetes is very advanced in that regards. So what you do is often we use DNS for discovery, and these frameworks are able to populate DNS records, which we can utilize, and then they can create containers. Other things that are also challenging is autoscale up and down, because you want to graceful terminate nodes. So you have to replicate away data first and then you kill the node. These are things where more advanced integration with these frameworks makes sense.
Okay, so I know you said you don't have to take an opinion on which of these schedulers is the best, but I would love, most of the time when I'm doing an interview about a scheduler, it is with somebody from a scheduler company. So
Yes.
Either Google about Kubernetes or somebody else about Mesos or Amazon about ECS. Can you give me some unbiased presentation of how you see this future of schedulers playing out, the war, as you called it?
Absolutely. And I know the guys very well. I know the project managers of Kubernetes. I know executives in Mesosphere, and also Solomon Hykes recently invested in our company.
All right. There's Docker Swarm also. Okay.
Yes. So I think Mesosphere has a really good track record in the enterprise, and we also see that people who really schedule workloads, not necessarily only containers, they use Mesos a lot. So this is Apache Mesos, the open source framework that is super stable, rock solid. And then Mesosphere is also adding stuff on top of it that is really, really, really good to use. And also the recent thing that they open source, DCOS, that's a good move. So I think if you go for a enterprise environment, a lot of people use Mesosphere as established platform. Kubernetes is, I think, the thing that has all the bells and whistles and is coming from a production environment. However, taking proprietary Google technology and open sourcing it, this is a process that takes some time, and some people might be overwhelmed with all the possibilities that they have there. But I think the team is doing a real great job in getting all of this out and grow the community around that. So I think if you're more the guy that want to tune all the parts, then Kubernetes is a very promising approach. And of course, the big mass of developers that never used a scheduler, that did not run a data center or had on-duty calls, sysops, but still want to run a distributed system, they will start naturally with machine and swarm and just take it easy. And I think it will take some time until people really use it in production, how to do the storage backends and things like that. But I think coming from the new start thing, having probably playing around with stuff, not necessarily in production, this is definitely going to have a big future as well. So it depends what you're using. We're also using in our company all the three of them. So depending on the use case.
That makes a lot of sense. It's a really good answer.
No, it's
a really good answer. But what about this notion of running Kubernetes on Mesos, for example? Under what kind of conditions would I know this is totally off base of talking about Crate, but I'm just very curious. Is there a reason why you would want to run Kubernetes on Mesos?
Probably, yes. If you use, I know people running virtual machines on bare metal and containers in whatever. So people love to build even more levels of abstraction. That's what developers love to do. And I think if a company is providing a framework or the base layer that is scheduled with Mesos, and this is like the workhorse behind the scenes, and then you try to run things, applications that developer deploy on Kubernetes or on Swarm. I think this is totally fine, and you can't avoid it. I mean, also
Definitely.
Google, I think they use, don't know, machines and then Borg to schedule containers running virtual machines, and these virtual machines again Kubernetes. So that's strange stuff happening there.
Okay, that makes a lot of sense. And so, I mean, as we're talking about these modern layers of virtualization on top of virtualization, one of the big challenges is networking. So getting back to the discussion of Crate, what do you do around networking? Like, what are the biggest challenges that you've encountered around networking, and how have you solved them?
Yeah, so we are pretty network intense. That's also what we learned. We just recently did a test where we had the possibility to run thousands of nodes on Azure with Crate, and also tried different schedulers. It turned out that the schedulers already used often so many ports and network connections that there was not much left for Crate, because like 1,000 nodes all interconnecting and sending hundreds of megabits of traffic there. So that's a challenge. That's also what I heard from people running data centers, that the networking cost is growing exponentially and not just linearly. So that being said, we really require a stable network also for the whole split brain and whatever situations. That's a requirement. All the big cloud providers, they have reliable throughput. They solve this issue. But yeah, I think there's still a lot of innovation to happen. So be it Weave on container, or be it Docker networking or Project Calico or all stuff like that, this is showing that we still also have quite some way to go there.
Okay, so we've hit on Docker and schedulers, and so the biggest buzzword left is microservices. So let's talk about microservices. Why is Crate a good choice for a database that supports microservices?
So microservices are about agility, about speed, about change, about quick development, deployments, continuous delivery, and getting things done. And that's also what we support. Changing schemas, moving data there, having different access patterns for data that you haven't thought about, having thought about there, scaling up, scaling down. I think it's all about change, and that's what we are designed for, and also the simplicity around that.
Right, and you've talked about the masterless architecture, which can also be classified as shared nothing. Why is shared nothing a good paradigm for building microservices in?
So the front layer in a microservice is a good front layer if it's stateless. If it's and everything that is stateless by default is like share nothing is masterless, because you can just a PHP application every time it's hit with a request, it's giving the same response, or doing the response based on an algorithm and not based on a state that has to be synchronized. So what people did initially with microservices was stateless, was share nothing by default. And the data layer, that is moving slower in this direction because it's much more difficult. So a lot of people still use their not Dockerized or containerized MySQL server that is standing somewhere else on a bare metal machine, and then they point their applications to it. But the next logical step are stateful containers, and that's also what Solomon said. He's often been misquoted about stateless applications or stateless containers. This is no conflict. You can also have state in containers. And I think this is the next step. And that's also what we're seeing, that more and more stuff is also regarding persistence and state is going to move to containers. And again, because of the nature, the way they are scheduled, because they have a much shorter lifespan. They're spun up much faster. They're killed much faster. You definitely also have architecture that supports that change, which is masterless or share nothing architecture.
Okay, so you mentioned the containerized state. I'm not super familiar with this debate between state and statelessness in containers, but I do get the sense that people think of containers as these very transient things that could disappear on a moment's notice because it's running on some shaky EC2 cluster somewhere. So how do you deal with state in a container? I mean, do you just always replicate constantly, or how do you think about that?
Yes, you expose a host volume to the container and let the container write on this host volume, and you create replicas. This is the most performant way. It's also possible to write inside containers and have the state inside containers, but this is not as performant, and this is not really a recommended way to do it because it's using this layered file system and storing the diffs there. So I will not run a database in there, and you should also be able to throw away the container. So exposing volumes to containers, this is the way to go right now.
Okay, great. So let's talk some about elasticity story. Crate is built to scale up and down quite easily. Could you explain the elasticity model?
Yes. So what the Crate cluster is doing is just trying to balance out the number of shards per machine. You create a table. It's automatically sharded. Let's say you create 15 shards and you run it on 3 nodes. Then just 5 shards on every node, plus probably a replica. You have 5 replicas additional. Then per node, then you have like 10 shards per node, 5 primaries, 5 secondaries. Then you add 1 more node. That means you have 4 nodes available for these 20 shards that are primaries, and I said 15 before, doesn't matter, 30. So you will have 8 on a couple of the machines, and some other will probably hold a little bit less, but this is just being reshuffled in the background. So if you add more and more nodes, then the shards are being spread out between the nodes. And if you remove a node, then they are moved back. You can also move the shards before you kill the node, of course.
So are there any lessons that you've learned from people who are scaling Crate to really, really big clusters, like problems they have or interesting solutions they've architected?
Yes, the best moment is always if someone is reaching out using the open source version. We never heard about these guys. You end up in a call and you see a lot of faces in your screen. And then you ask them, may I take a look at the dashboard, or what's the problem? And then you see, holy shit, these are how many nodes? Scroll down. What is the amount of records there? Oh my God, what are these guys doing there? Luckily, we're doing this now since 3 years or something like that. These moments are more seldom. What we find people having the hardest time, or what is not as easy for them, is doing the right dimensioning. How many shards do I have to create? How do I partition? How do I dimension the things behind the scenes? Yeah, that's something that's not that easy. But I think speaking today, our largest cluster, he's running on more than 100 nodes. He's ingesting more than 3 billion records every day. He's doing this since 8 months. We never heard something bad. Of course, there have been some spooky moments, but luckily nothing happened there. So right now we feel pretty confident also about handle production loads on large clusters.
So I'd love to talk some more about the usage of the query language. What are the kinds of queries that the Crate SQL language supports, and what doesn't it support very well? I know you've touched on this a little bit already, but...
Yeah, so we decided not to invent a new query SQL dialect. So we wanted to go with really as standard as possible. And the good thing with standards is that there are so many standards to choose from. So... it's the MySQL standard, the PostgreSQL, the SQL 92, SQL, whatever. So most of the times we just do it the way MySQL is doing it, because this is what most of the people use. but it doesn't have all functionality available. So the whole geospatial stuff, for example, we borrowed this from PostGIS. So dealing with geospatial data is exactly the way it is like in Postgres with Crate. And we also had to support some things, unnest functionality that other databases had. So I think for the use cases I mentioned earlier, like Internet of Things backends, analytical workloads, we're covering for most of the people like 80% of the SQL statements they need. They might have to rewrite some of the queries, but for some people, we are already a drop-in replacement to their MySQL installation, especially if they normalize data, if they got rid of joins, if they already did some of the stuff you have to solve when you scale.
So if I'm somebody and I want to use Crate, but Crate doesn't service all of the queries that I need, is there a typical model you see where people are using Crate alongside something else, like using Crate alongside Cassandra or alongside Spark or some other typical tool that really complements Crate well in terms of the different types of queries that you want performance out of?
So for the queries, we don't see people adding stuff there. They usually get in touch with us, and we are pretty quick in adding such functionality. What we see works really well is if you connect us to queues like Kafka, for example, directing Kafka streams into Crate and storing them, but also run Spark, machine learning and stuff like that. These frameworks on top of us where you have a lot of queries there. So the ecosystem, our neighbors, let's call it that way, are visualization tools that use our JDBC connections, Zoom data, Metabase, Grafana, most of these tools. And on the data ingestion side, Kafka, stream sets, bulk loading from S3 or other buckets, having Hadoop jobs loading data into Crate. These are neighbors we often see along our technology.
Great. Okay, that makes a lot of sense. So let's zoom out a bit and kind of begin to close off. What's the business model for Crate?
Yeah, so the core of Crate is open source. It's Apache license with a permissive license. We as a company, we are selling enterprise licenses on top. So right now, the way the deal we do with customers is we have a partnership agreement where we deliver special functionality for these guys that are not part of the open source release. So the cross data center replication is, for example, one thing we're working on with enterprises, access control to the cluster. And this will be part of the enterprise license, which we hope to ship later this year. Right now, it's really the open source distribution. Plus, we have some plugins that are not released yet, or an ODBC driver, for example. We have an ODBC driver for the Windows world, and you have to license that. However, we are still a young company. So just to give you a dimension, there is we have about 500,000 downloads of our server software. We have about 400 or 500 clusters running in production day and night across the globe. And I think we have 1-2 handfuls of paying customers where we also have service level agreements and that are using Crate heavily in production.
So since you're open source, do you have any concern about Amazon or Google just like hosting Crate and like basically offering the same thing, but doing it Google or Amazon style?
That would be great if they pick up our technology and host it. I think we have the unique know-how on how to develop and how to further develop this query engine. And I'm doing open source since ever, basically. And the usage is always good. And if you're the guy who did it, if you're the guy who has the knowledge, and you're always ahead of that. So I'm not worried about this at all. I would really think this would be a good idea.
Totally. So with that in mind, how big of a challenge is adoption? Because it's always tough to convince people to get on board with a new technology, particularly a database, because it's so mission critical. How big of a challenge is adoption, and how is that going?
Yeah, that's exactly the tough point. But on the other hand, it's also the good point, because when people did the decision, it's a big decision. They made it. They're not really going to change it. And that's also the relation of 500,000 downloads versus like 400 or 500 clusters in production. And this sounds not like a lot, but people who really made the decision to store your data in there, this is big. So for some of our customers, if we are not running, their business totally stops. So this turns out that this is a lengthy progress and this is a hard progress. So we have a lot of people that heard about us. We were really happy to be out of the mud of 200 databases because we won TechCrunch Disrupt. We have Solomon Hykes as investor. We have a couple of things that other database companies did not manage to achieve. And this is giving us a lot of awareness. And then people hear about it, but it might take 6 months until I heard something about a database. It's not a JavaScript library where you just download it and then jQuery sounds great. I have to do React.js now. This is very, very different. But still, it's very promising. We receive really great feedback and people just tell us, hey, you guys, you're so bad at marketing. You should really think about marketing, but your technology is great. And that's a good point to start in 2016 and 17.
Totally. Okay, so final question. So the big promise of Crate is to make centralized databases obsolete, or I guess to make centralized databases easier. What are the big challenges that still stand in your way from doing that?
I think there are two things. The one is on the product side, it's really hard to build this distributed query engine planner. Oracle, Microsoft, whatever, they spent years on a single node query optimizer planner. That's really challenging. And the other thing is the adoption and also getting traction or more and more traction, especially in US. Our development is headquartered in Europe, Berlin and Austria. We're now in the process of building up the whole sales and marketing in the Bay Area. But from a strategic standpoint, it's not a technology problem. It's really about how do you play this? How do you enter this enterprise market and still have a healthy open source community? So I think these are the most challenging parts.
Cool. Well, Jodok, thanks for coming on the show. This has been a great conversation.
Yes.
I love Crateio. Very interesting database. So thanks again, and I'll talk to you soon.
Take care. See you soon.